In the arrangement shown in the figure given below, the body of mass 1 is 4 times as great as that of body 2. The height h equal to 20 centimeter. The masses of the pulleys and the threads as well as the friction are negligible. At a certain moment, body 2 is released and the arrangement is set in motion. What is the maximum height that body 2 will go up to? So if we consider this problem, let us begin by tensional analysis. So if I do the tensional analysis, so I can say that if there is tension T in all these threads, so there is a tension 2T in this thread. The next thing which I can say is there is a force 4 mg acting in the downward direction, and over here mg is acting in the downward direction. Now the next thing which we wish to establish over here is an equation between the acceleration of the two masses. So I am just redrawing this system to get a clear picture of how the system is going to behave. So if we redraw this diagram, we are considering the system like this. So if we consider the system like this, so we can consider that this mass system will go down by a distance x. So suppose if this mass system goes down by a distance x, so this length of the thread and this length of the thread, that is 2x. So the mass, second mass must rise by a distance 2x in order to compensate for the rope length. So if we establish a constraint relation, so I can say that if mass 1 is moving down with an acceleration a, so mass 2 is rising up with an acceleration 2a. Similarly, if it will go down by a height h, it will rise up by a distance of 2h. So if we start writing the equation using the terms of tension and the acceleration which we have obtained, we can write the equation in this way, that for the first mass we are writing 4 mg in the downward direction minus 2t is equal to 4 ma. We can rewrite this equation in this fashion, that 2 mg minus t is equal to 2 ma. So this is the first equation that we have. If we write the second equation, then the second equation is going to be T minus mg is equal to 2 ma. So this is for the another mass 2 that we are writing this equation, that a force mg is acting in the downward direction and a tensional force T is in the upward direction. So T minus mg is equal to 2 ma. So from this equation we can write it in this same fashion, T minus mg is equal to 2 ma. So this becomes our second equation for this particular problem. And on solving this equation, we can obtain the value for acceleration, that is mg is equal to 4 ma and acceleration is equal to g by 4 meter per second square. So from this we can say that acceleration of second mass, that is a2, is equal to twice of a, that is equal to g by 2 meter per second square. Now we are considering the problem in this way, that if this first mass is coming down by a height h, then the second mass will rise by a distance of 2h. So if I write for the motion of second mass, for the motion of mass 2, then we can start writing the following facts, that the initial velocity is 0. The displacement of second mass is equal to 40 centimeter in the upward direction. So if it is 40 centimeter in the upward direction, that is equal to 2h. So we can write it as 40 by 100 meter. Now what is important over here is the question is asking us the maximum height that body 2 will go up to. So you might be thinking that 40 centimeter is the correct answer, but it is not so. Because as it go to a height of 40 centimeter, it will attain a certain velocity. And the first mass will hit the ground, while the mass 2 will continue to be in the state of motion and the string will slack. So what we are intending to do over here is we are calculating the final velocity which it will attain while traveling this distance with an acceleration of g by 2, that is 5 meter per second square. We are writing it as g by 2 for the time being, meter per second square. So if I write the equation of the velocity, we are writing it as v square is equal to u square plus 2as, and from here we are writing it as v square is equal to u square is 0, so we write it as 2 g by 2 into displacement, which is equal to 40 by 100. So from here, if we take the square root, we obtain that the velocity is equal to 2 meter per second. So now what I can say regarding the second mass is that the first mass hits the ground something like this. If we go to the previous diagram, we can say that the first mass will hit the ground. 1 minute. So we can consider it in this way, that the first mass will hit the ground, but the second mass will continue to be in the state of motion because of the velocity of 2 meter per second which it have acquired, and now it is in the state of free fall. The string becomes slack. The string becomes slack, and the mass 2 is in a state of free fall. So what I can consider over here is that the mass 2 is having an initial velocity of 2 meter per second in the upward direction, while the acceleration due to gravity is acting in the downward direction, that is equal to minus 10 meter per second square. And we are trying to find out the maximum height it will attain, that is final velocity is equal to 0. So if we again use this expression, we can say it as v square equal to u square plus 2a h naught. So this is the additional height which it is attaining after traveling a distance of 40 centimeter in the upward direction. So now if we solve for this, we say this is equal to 4 minus 2 into g, that is 10 into h naught, and from here we calculate h naught is equal to 4 by 20, which is equal to 0.2 meter. So the maximum height attained, h total maximum attained, is equal to 40 centimeter, that is 40 by 100 while traveling in the upward direction, and then 0.2 meter after the string becomes slack. So the total distance or the total maximum height attained is equal to 0.6 meter. So this is going to be the answer for this particular problem. I hope you understand it clearly over here, that after mass 1 strike the ground, the mass 2 will continue to be in the state of motion due to the inertia of motion, and will cover an additional height of 0.2 meter, which must be added with the originally attained height. So the total answer is 0.6 meter for this particular problem.